So this video is Integrated 3, Chapter 2, D-Day number 2. And you don't have to do this, but I'm just going to go grab a graph from the ad media. I'm going to go to Google. And when I say graph, I mean a grid. So I'm going to put graph in here and see if I can find a graph. You don't have to do this. I'm just going to do this just to make it a little easier for you guys to see where I'm plotting things. Okay. And drop it here, make it a little smaller. Okay. And I'm going to come here, go down to select annotations and copy, paste. Okay. Paste. Okay, so I'm going to do that real quick. Okay, so just put those on. Again, don't have to. So this one is a cubic graph, and its locator point, which is called an inflection point, is going to be 2, 1. So I'm going to go to 2, 1, and I'm going to put a point. Make this a little bigger. And then from here, if we're just sketching and we're going to do a rough sketch, okay, remember this is like an open down to an open up. On B, this is a square root graph. And so my locator point is going to be 1, 2. So I'm going to plot that 1, 2. And then remember the square root graph is like half of a sideways parabola. So it's going to go like this. Again, I'm just doing rough sketches. Okay. On C, this, if you're thinking about a locator point, let's say it's going to be -3, -1, but it's not going to be an actual point. You're going to have an asymptote. Okay. At -1 on, I'm going to change the color. So at -1, at y equal -1. And then that point I'm talking about, I will get that point for a second, but I'm going to get rid of it. So that point I'm talking about, -3, -1, right there. That is not a point, but that's kind of where I want to be. So from there, let me actually get a different color for this. So from there, what I'm going to do is I am going to come to this point, -3, -1. And then that's where I do my 1 above. That's what you have for the normal y-intercept for a exponential. I know we didn't get to those ones today. So I'm going to put a point here. And let me actually take away that other point. Okay. And then this is an increasing parabola. I mean, exponential. So it's going to get closer there, and then it's going to go up like this. Again, I'm sketching. I'm not being accurate with the graph, except for the location. Okay, on letter D, this one is a circle, and it has a center at -3, 2. And when I take the square root of 16, that's going to be my radius. So my radius is 4. So I am going to put a point at -3, 2. And then from here, I'd be going out 4. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. In each direction, you can see that if I'm using this, it's a little off. But what I can do is I can come here and grab the circle. And if I hit shift while I do it, I am going to get a circle. I'm going to start at one of these points. Okay. And have it go through the center, and you see it goes through all of them, and there's my circle. So if I hit shift and use that, it actually will draw a circle for me. But if you don't hit shift, it's going to be an ellipse or an oval. On E, okay, this is the reciprocal function. And if I'm trying to think of a critical point or a locator point, I might say that it is 2 comma 3, but it's not, again, a point. That's where my two asymptotes are going to meet. So whatever makes this denominator 0, that is where I have an asymptote, because x cannot be 2 or else it makes my denominator 0. So I'm going to have an asymptote right here at x equal 2. And then that plus 3, I'm going to have one at y equal 3. And then I'm going to sketch my graph, okay? And I'm going to put a point. Again, you don't have to be accurate with this, but 1 comma 1 and negative 1 comma negative 1 is kind of, because that's what multiplies to 1. We kind of saw that today, but again, you don't need to be precise with that. Here, I'm going to make this a little see-through for a sec. And so it's going to come like this and like this. You got the two branches. On letter F. On F, this is an absolute value graph. And it's going to have a vertex at 0 comma negative 1. So I'm going to go to 0 comma negative 1. And then from here, let me make this a little fatter. And then from here, that stretch is really a slope for this. So I'm going to go down 1. I'm going to go down 1, out 1, 2, 3, 4. And same in the other direction, down 1, out 1, 2, 3, 4. And I'm going to draw my V. And that's my absolute value. On these ones, we are trying to write the equation of them. And so for this graph, the general equation would be y equal a over x minus h plus k. And the important things I want to look at are these asymptotes, okay? So I have an asymptote right here, it looks like, at y equals 0. So that means my k is going to be 0. And I have an asymptote here at x equal 3. So that means my h is going to be 3. So far, my equation is going to be y equal, and on the bottom, because of that, moving to the right 3, this is going to be an x minus 3. And then I'd have a plus 0, but I don't need the plus 0. And then they said, if they don't give you any point, assume that your a is 1. And just a little reminder, this is going to multiply to 1. So 1 comma 1, negative 1 comma negative 1 if I'm moving. So this is a 1. But again, they said in the directions, and that would be your equation. They said in the directions, assume a is 1 unless a point is given. Since they did not literally give us a point, assume your a is 1. On B, okay, this is an absolute value graph. So this is going to be y equal a times the absolute value of x minus h plus k. I'm just going to move this up a little bit. Okay. So what I'm going to do is I need to find my vertex, which is right here at 3 comma negative 2. So that's my h and k. So I know this is going to be y equal a times the absolute value of x minus 3 minus 2. Then they gave us a point, 6 comma 1. I'm going to put that in for my x and my y to find my a. So I'm going to go 1 is equal to a times the absolute value of 6 minus 3 and absolute value minus 2. So I am going to do this absolute value of 6 minus 3, which is 3, and the absolute value of 3 is 3. So I'm going to have 1 equal 3 times a minus 2. I'm going to add 2 to both sides, so I get 3 is equal to 3a. And so my a happens to be 1, happens to be 1. And if you look at the graph, you can see we're going up 1 over 1, up 1 over 1, up 1 over 1. But don't assume anything because the graph may not be to scale. Always use the point that they give. So what does that mean? Our final equation is going to be y equal, I don't need to put the 1 in front, absolute value of x minus 3 minus 2. That is our final answer. This is our final answer over here. Okay, on C. Okay, so C is a parabola. So this is going to be y equal a times the quantity x minus h squared plus k. So my vertex is at 1, 2, 3, 4, 3. Okay. And so this is going to be y equal a times the quantity x minus 4 squared plus 3. Then what I'm going to do is I'm going to put in the point that they gave. And the point that they gave us was this 1 comma negative 4. So I'm going to put that in for x and y. So I'm going to get negative 4 is equal to a times 1 minus 4 squared plus 3. 1 minus 4 is a negative, so here, 1 minus 4 is a negative 3, and a negative 3 squared is 9. So I'm going to have negative 4 is equal to 9a plus 3. I'm going to minus 3 from both sides, so we get negative 7 is equal to 9a. I'm going to divide both sides by 9, so I'm going to get negative 7 over 9 is my a. So that means my final equation, I'll write it down here, is going to be y equal negative 7 over 9 times the, that's a 9. Hold on. Move my screen slightly. So over 9 times the quantity x minus 4 squared plus 3. And that would be our final answer. On number 3, we have to decide if this is even or odd. So if I was to draw a line and flip it across that line on the y-axis, you see it's going to be the same on both sides. So this is going to be even, okay, because it's symmetric about the symmetric across the y-axis. Now on B, we have to do it algebraically. So we're going to be putting in a negative. So you want to think about it as f of negative x is what we're going to do. So I'm going to put in a negative x and cube that, and a negative x minus 1. And so when I take a negative x and I cube it, this is going to be a negative x cubed times 5. That's going to be a negative 5x cubed. And let me just get this. And I'll try it one more time. And so this negative 5 times x cubed, because a negative to an odd power is a negative, and negative times 5, so I get a negative 5x cubed. Here I get a positive times a negative, so that's going to be a negative x minus 1. So what we need to do is look at our original equation. This is the original one. This is not the same, so that's not even. Then I want to decide, is it the opposite? So if I was to look at this and make this the opposite would have been a negative 5x cubed, so that looks good, minus x, so that looks good. But instead of a minus 1, I would have had a plus 1. So this is neither. Looking at number 4. So on this one, we want to write it in graphing form. So what I'm going to do, first thing I'm going to do is I'm going to get rid of that 5. I'm going to give myself some space too. And so I'm going to be left with 3x squared minus 9x. Okay, now I do not like the 3 in front of my x squared. So I'm going to factor 3 from both my 3x squared and my minus 9x. So I'm going to get x squared minus 3x. And then I am going to be adding something to both sides. Now, in this case, I'm going to take my -3, I'm going to divide it by 2, and then I'm going to square. So that is going to be a 9/4 if I want to leave it as a fraction. I'm just going to leave it as a fraction right now, 9/4. Or I can put it as a decimal. Up to you. And hold on, correction. Remember, there is a 3 here. So the 3 is going to multiply with this. So this is actually going to be a 3 times 9/4, which is a 27/4. So I'm going to have y. And if I want to get this to be a common denominator, you can just on your calculator go -5 plus 27/4. But if I'm going to do this without a calculator, -5 would be a -20/4 plus a 27/4. Okay. So that is going to give me a +7/4 is equal to 3 times x minus, and half of 3 is a 3/2 squared. And then my last step, subtract my 7/4. Now, again, you might have done this using a fraction. So you might have had a 1.5 instead of the 3/2, okay? And then 9/4, you could have put that as a decimal. But this is it in the fraction form. On B. So on B, okay, we were doing an egg tossing contest. And it was thrown 60 feet. So I'm going to start it at 0, 0. And then it's going to go 60 feet. So this is going to be 60, 0. And then the max height it reached was 18. So it's going to be 18 high, but half of that would be 30. Okay. So this is going to be 30, 18. So I personally would write it in the form y equal a times, that's an a times x minus h squared plus k. And this 30, 18 is going to go in for my h and k. So I'm going to get y equal a times x minus 30 squared plus 18. Then I'm either going to use 0, 0 or 60, 0 and put that in for x and y in order to find my a. I'm going to use 0, 0. Okay. So this is the one I'm going to use. So I'm going to go 0 is equal to a times the quantity 0 minus 30 squared plus 18. So 0 equals, and -30, 0 minus 30 is a -30. And a -30 squared is 900. So I'm going to have 900a plus 18. I'm going to minus 18 from both sides. I'm going to divide by 900. And when I do, let's see, 9 goes into both of them. That'd be a -2 over 450. So 2 actually would go into both of these. So if I reduce this by 2, this would be a -1 over 225. If I simplify it. So this would be y is equal to -1 over 225 times the quantity x minus 30 squared plus 18. And again, I reduced the fraction, but -18 over 900 would be acceptable. And on the next section. Okay, so this is multiplying out imaginary numbers. So I'm going to do it in a box, 2 and a -4i, and 1 and a +3i. So I'm going to take 1 times 2, 1 times a -4i, 3i times 2, and 3i times -4i is a -12i squared. But, this negative 12i squared. A negative 12 times, and remember, an I squared is really a negative 1. So instead of it being negative 12i squared, I can say negative 12 times negative 1, which is a 12. So this whole thing here is really a 12. So when I add that up, I'm going to get 14. Hold on. I'm going to get 14 plus 2i, and that is your answer. On B, I need to break these down. So you can think about what's the biggest square in 75, which is going to be a 25 times 3. And let me just prime factor it, and that's a 5 times 5. So when I have two things, okay, this is a square. So that means I am going to have a 5, and then the one that did not have a pair is going to still be underneath it. Okay. And then when I'm dealing with my 27, okay, so let me just deal with my 27 up here. So if I take the square root of 27, 27 is a 9 times 3, which is a 3 and a 3. So again, if I'm looking for a pair, here's a pair, so that's a square. So that means that I'm going to be getting out a 3, and then I still have underneath it my root 3 because my other 3. So just let me highlight. So here, that one was left here. This one was left here. Okay. Now, there was a -4 here. So there still is a -4 times. Okay, it's going to times. And let me just, this right here that I'm boxing, that was the work. Okay. That was my work for my 27. So let me clean up my final answer. So this is going to be a 5 root 3. And then 4 times 3 is 12. So I get a 12 root 3. Now you can add radicals or subtract radicals when they're like. So that's going to be a -7 root 3. And that's your answer. Okay, on number 6, so solving, I would multiply this out, which is a 3 and a -5x, and a 1 plus 2x. And when I do, I'm going to get a 3, a -5x, a 6x, and a -10x squared. And then I'm going to clean that up, and I have a -10x squared plus x plus 3 equals, and on the other side here, okay, what I'd have is a 7 minus 2x plus 6, because that -2 is going to distribute to the x and the -3. Do not do 7 minus 2 and get a 5. That's a no-no. That 2 is not a 2. It's a 2 times x minus 3. So now I have a quadratic. What I personally would do is when we solve quadratics, we like our x squared positive. So I'm actually going to bring everything over to this side, because when I do, I would now have a positive 10x squared because I could add 10x squared to both sides. Okay. I'm going to be minusing a 2x. So that's going to become minusing an x. That becomes a -3x. I'm going to be minusing a 3. So that's going to be a plus 3. So I'm just really combining like terms, but I'm taking everything over to the right side. Now this should be factorable. So let's see. I'm going to take a box to diamond. So I'm going to have a 10x squared and a 3, which gives me a 30x squared. And it needs to add to a -3x. So I'm thinking positive 30 and a -3. So let me just double check my numbers here. So that is not going to be factorable because there's nothing that's going to multiply to a positive 30. and add to a -3. So I'm not going to use this method. I'm going to use, and this is where you have to remember something from integrated to the quadratic formula. Okay. So that is x equal -b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to get +3, because that's the opposite of my b, plus or minus the square root. And I'm just going to take -3 squared, which is 9, minus 4 times my a, which is 10, and my c, which is 3, all over 2 times my a, which is going to be a 20. Okay, this is from last year. This is something I probably have to focus on a little bit more. We're going to see this a lot this year. So now I'm going to do 9 minus 120. Okay, so 9 minus 120 is going to be a negative. So let me just write it here. Sorry, 9 minus 120 is what's underneath the square root. So that's going to be a -111. Okay, over 20. And we cannot take the square of a negative and get something real, but you can get an imaginary answer. So I'm going to write it as 3 plus or minus, and I'm going to have I root 111 over 20. And that's our answer. Not pretty, but that's our answer. So this is something that was a main focus in integrated to being able to solve quadratics, whether we do it by factoring or by quadratic formula. And sometimes we get imaginary answers. Okay, this one here, this is really integrated 1 in the sense of when we learned this, but this is a little step up from integrated 1. So what we're going to do is we're going to times everything by a 6x. The reason I'm going to times everything by 6x is because a 6x will get rid of all of my denominators. So let me just kind of rewrite this. So I have 6x times this plus 6x times my 7 equals 6x times my x over 2. Okay, and let me write this. 2x squared minus, let me space this out. I don't know why I didn't write it. Wasn't thinking. Okay, 2x squared minus 4x over 3x. Okay. So, and I see something I could have done a second ago, but let's talk about this. 3x goes into 6x twice. So then I'm going to get 4x squared minus 8x plus 42x equals, and 2 goes into 6 3 times, so I'm going to get a 3x squared. So now I'm going to get everything on one side, 0 on the other. So I'm going to subtract 3x squared, so I'm going to get x squared, and my -8x plus 42x is going to be a positive 34x is equal to 0. I can factor out an x from both of them. So I have an x times x plus 34 equals 0. And this could be 0, or this could be a -34. Hold on, right, a little better. Could be a -34, and those are your answers. Now, you never want an answer that's going to make your denominator 0. So when you have an x in your denominator, you got to double check it. So that means this one right here, no. So this is my answer. The last 2 problems are a little tough. Okay, a little tough. And this one is the one that was actually from integrated 2 and integrated 3 math analysis. But I wanted to give us as many extra practice ones as possibly before our test. So hopefully that helps. If you have any questions, you can email me or come in with questions tomorrow. We're going to do the group quiz on Thursday, tomorrow.